And welcome to today's Call for Code meetup. My name is Jennifer. We're so happy to have you with us today. Today we've got the team from Build Change here to talk with all of you. They were finalists in the 2018 Call for Code Global Challenge, and their solution from that competition has grown into an application called ISAC-SIMO that, through support from Call for Code, is now hosted as an open source project with the Linux Foundation. Bob Taylor and Lakshana Casey are here with us today. They're going to be demonstrating ISAC-SIMO for you and talking about ways you can contribute to this open source project. And joining them from the Call for Code team today, we have our Chief Technology Officer, Daniel Crook, and our Developer Advocate, Pedro Cruz. Now, before I begin, I always need to mention just a few things. This session is being recorded. The replay will be available immediately after the event ends. We'll also send a follow-up email to those in attendance with the replay link and links to any resources we share here today. Please do share those links with friends and colleagues as well. Feel free to use the chat function. Say hello to us. Let us know where you're joining from today. Or, of course, ask any questions relevant to the conversation. And then finally, please follow IBM Developer on Crowdcast if you want to be notified of any future events. Okay, I think we're ready to get started. I'll go ahead and pass things over to Daniel.
Wonderful. Well, thank you, everybody. Thank you for joining. My name is Daniel Crook. As Jennifer mentioned, I'm the CTO for the Call for Code program, which is a multi-year competition initiative that we launched in 2018 together with the Linux Foundation, the United Nations Human Rights Office, and David Clark Cause. And it's grown over the years to be the largest tech for good competition of its kind, attracting developers from around the world to take part, create amazing things to tackle some of the world's greatest challenges. Now, what sets Call for Code apart, though, is it's not just a competition with prizes and recognition of the top ideas. What we want to ensure happens through each of the successful projects that come into Call for Code is that they live on as sustainable open source projects at the Linux Foundation for anybody to use and contribute to, but also that they're tested and validated around the world where they can make a difference. So for example, today Lakshana joins us from Nepal, which is where ISAC-SIMO originated as part of the inspiration for the development of PD3R back in 2018. Now, beyond Nepal and the United States and Puerto Rico, where Pedro is from, and Jennifer and I from the US, we've got developers from all over the world that have taken part in the competition. Now that we've just wrapped up the Global Challenge this year, we've had over 500,000 folks join Call for Code in one way or another through our virtual events like this or by submitting applications from the challenges. And we've grown to participation from every continent. I think we even had somebody who, jokingly or not, registered from Antarctica in the participation agreement this year. So it's really reached around the world. It's become a great way for developers to learn new skills and meet other developers and network to find greater opportunities to use their skills to take on the world's greatest challenges. And as I mentioned, we started out in 2018. We focused then on defining a scope for preparing for, responding to, and recovering from disasters around the world. And over the years, Call for Code has grown to take on other types of issues in the global competition, as well as through specific events we have around the world, around the calendar, which we call spot challenges. So for example, we have one right now for artificial intelligence. Maybe some of you are taking part in that right now. Submission deadline for that one is this month, as well as some winners highlighted from that solution. And you can, in fact, build upon ISAC-SIMO to submit for that competition. But over the years, we've shifted from focusing on disasters towards some of the causes rather than treating the symptoms. Climate change, so we focus on access to some of the issues in the Sustainable Development Goals from the United Nations around zero hunger, clean water and sanitation, responsible production and green consumption. And last year as well, we had a separate track around the social and business aspects of the pandemic. And we had Call for Code for racial justice, take on some of the systemic issues where technology can make a difference to make a more equitable world. So you'll learn about a lot of projects that have fallen under the Call for Code umbrella when you're learning about Call for Code as a competition or through some of the open source projects. We encourage you to check them out. Some of them include Project OWL, which resulted in the Cluster Duck Protocol open source project. Prometeo being the second-year winner. They just released their project as the Pira open source project. And Agrily, who won last year, they're still working through our service core deployment with them to test their solution and turn that into an open source project. And I'll show you some of the links too, as where you can learn about these additional projects in addition to ISAC-SIMO if you're interested in checking those out. Just to give you some background here too, so Call for Code is really, the competitions are about generating the ideas. Pedro and myself then work with the teams to improve them. So for example, with the Build Change team, with Lakshana and Bob, we've worked with them to refine how they use their technology using IBM and open source technology, and supported them in how they can deploy that and use it and test it in Colombia, Nepal, and around the world with the help of the open source community. And so our goal is to make sure that these projects do live on, they have an impact on the world, and that you can learn skills and contribute to them. So you learn about these projects through Call for Code Linux Foundation. I'll drop that link in the chat when I hand it over. Nope, there we go. Jennifer just dropped the link in there too. So you can learn about all the projects there, learn about the catalog of other projects that are underway, and hopefully if there's something of interest to you, for example, Call for Code or the climate change projects or Call for Code for racial justice, you'll find something there of interest where you can make a difference. Along with those projects that we have on GitHub, we also have a bunch of tutorials and things that you can learn more about the projects, use them, learn about them, learn how you can join the community, whether you're technical or not, and then contribute back to them. So on the IBM developer side, we have a set of tutorials, including one for ISAC-SIMO. It's in the chat there, where you can follow along after the demo and see how the technology works. So you can learn that about several projects, including ISAC-SIMO, at developer.ibm.com/call-for-code. And to take part, if you get an IBM Cloud account, you'll get $200 in credit to use for playing with some of the technology. There are a lot of free services as well you can experiment with and contribute back to, including the free tier for Watson Studio. And obviously, when there's open source projects, you can work on those on your own workstation for free. So plenty of stuff there. There are the 14 Call for Code projects, including ISAC-SIMO, that you can take a look at. You can join us in our Slack community. And then we'd love to see those contributions come back into the open source projects as you take part in the initiative with us. So very excited to join you to this presentation. And from now, I'll hand it over to Bob and Lakshana to take you through the context of ISAC-SIMO, where it originated, and what it looks like, and how you can take part in it.
Thank you, Daniel, and Lakshana, if you can start to share. And I'll give a hopefully very brief update and kind of background on who Build Change is and what we do, and then pass it on to Lakshana for all the good stuff. So Build Change, for those that aren't familiar, is an international nonprofit focused on building resilience for natural disasters. Started out largely around earthquakes, and we've added a lot of work now around hurricanes and typhoons, so kind of wind-focused disasters, and looking to potentially expand beyond that in the future. It's founded in 2004, focusing largely initially on response, but now works both on response to natural disasters and going in and helping assessing buildings, and we're looking at that right now for Haiti. For those that didn't see, there's a severe earthquake in Haiti that's right up the area the Build Change works in, so we're looking to see what we can do to help there, but also doing retrofits where we go in and try to fix buildings and improve building structure before a disaster and try to prevent them down the road. So if you want to switch to the next one, Lakshana, and we'll go through these next couple pretty quick. A lot of what we're trying to address is substandard housing. So a large part of the population of our world, and it's unfortunately growing, live in housing that is at risk to natural disasters. Flip to the next one, I'll hit more on it from here. The estimate is that about 3 billion people will be living in substandard housing, especially with respect to risk to natural disasters, and that's a growing number right now, both just as populations shift. A lot of building happens in places that are informal housing, that may be off code, off standard processes and things like that, that are not built as they should be. But also as climate change happens, some of the risks are increasing, so that the need here is growing over time. Look to the next one. So there's a variety of challenges. I mentioned a lot of in growing urban areas. A lot of the housing that gets built is substandard. It's done in ways that are potentially outside of formal processes that don't get inspected, etc. There's a lack of engineers and construction professionals. So the techniques for actually how to make housing that is resilient to a lot of these disasters are known, but it takes engineering and construction professionals that understand them well. It can be expensive, it costs money. So that's one of the things that we also try to address is how do we align up funding with the need so to actually make the improvements that are necessary. Local labor is often undertrained, so we do a lot of education related to that. And then there's construction supervision, which when we get into ISAC-SIMO is more the part of this that ISAC-SIMO is trying to address is how do you handle making sure that as new construction happens or retrofits happen, that it's done in a way that's actually going to solve the problems we're trying to solve. Get to the rest. The build change approach then has three main parts. People, and that we try to make it very people-centric. So we are intentionally very, very much involved the homeowner, the local building and tradespeople. We hire a lot of people local in country when we're working in a location. As well as all the government entities and other NGOs that we partner with. So there's a lot of interaction, not just from a pure technical perspective, but with people involved in the process, so that it's not totally dependent on us, but we go in and help people get what they need and get the process they need. Sometimes that means money. So to either rebuild or to retrofit, it does cost money. In many cases, the homeowners can't afford to do it on their own. So we do a lot of work with other agencies, government agencies, World Bank, groups like that to align funding and make sure that the money goes to the right place to solve the right problem. And then lastly, technology, which is what we'll be talking about today, is that we try to improve technology to make these problems easier and more scalable. Build Change by its nature is a technical organization. It's engineering focused, civil engineering focused organization that we use software technology to improve the efficiency of, but we're technical by definition. That's kind of what we do. Flip to the next one. And this is kind of talking about that technology innovation. There's a 6-step construction value chain that we work inside, everything from initial data collection to information sharing, design, the financing, building, and reporting. So there's all the way through the entire process. We work across that. And for all these steps, we have tools that we have either partnered or built with to automate and make more efficient that process. When we originally started, it was largely paper, but it's becoming more and more digital in most of our locations as we go on. And we're always looking to improve these technologies and the tools that we're using to make it more efficient, that we can address more houses and get more work done in the field, but also in some cases, so it doesn't have to be us. So we want to right now create tools that allow not just build change professionals or engineering professionals to do a lot of this work, which is what's traditionally been, but we allow the homeowners or builders or local inspectors to have the right tools to do the analysis themselves. And that's kind of where ISAC-SIMO comes in. It's targeted largely at that build stage, where one of the things that we want to do is make sure that as construction is happening, it's happening in the correct way that's actually going to be resilient to the natural disasters we're trying to protect from. So that's the focus of ISAC-SIMO, is an in-field analysis tool to allow the homeowner or an inspector to do a quick, robust analysis of how the building is happening to make sure it's actually satisfying those requirements. So that I'll pass it on to Lakshana, who will dive into the details of that, and I'll be monitoring the chat, so feel free to ask questions there, and we'll handle them on the fly as we can. Otherwise, we'll save them for a deeper discussion at the end. Lakshana, I think you're on there. So there you go.
Can you hear me now?
Yep, I can hear you now. Thank you.
Okay, great. Thank you so much, Bob, for your part and introducing Build Change and the project. So, hi everyone, and thanks again for joining this session. Now that Bob has given you the overall context and of the organization and the project, let me dive deeper into the technology. Before I do that, let me give you a quick overview of the agenda for the remaining session. So first, I'll give a quick overview about ISAC-SIMO, the end users, and the housing typology background, and then how you can contribute to this project. And I'll move on with the demo of the technology. So basically, I'll give a quick demo of the web platform and the mobile app. And then we'll move on to see the building blocks of a quality check. So basically, the implementation pipeline of a quality check and how it's set up in ISAC-SIMO. And then we'll look into how you can customize ISAC-SIMO by adding your own models, preparing your data set, and deploying the final model to ISAC-SIMO web platform. And feel free to ask any questions via chat in the middle, and you can interrupt me if you have any specific questions that you are curious about that you want me to touch upon. So about ISAC-SIMO, ISAC-SIMO stands for Intelligent Supervision Assistant for Construction, and SIMO stands for its Spanish translation. And the objective of this tool is to make safe construction practices and quality checks accessible to local community, builders, and local authorities. So basically, making available the technology via smartphone to be able to assess and carry out certain quality checks in their buildings, and also be able to validate the intervention work being done, for example, retrofitting or new construction. And the approach we've taken to develop this tool is by deploying technologies such as AI and image processing to help automate visual quality checks. So basically checks that can be done visually by assessing, by looking at an image of a construction element, for example. And the solution consists of two components. One is the mobile app, which is expected to be used by the field users. And then the other component is the web platform, which can be used to set up the quality checks in the mobile app, and also for admin users and developers like yourself to be able to contribute and grow, help this project grow and build a further catalog of quality checks that can be deployed across the world. So as I mentioned, the end users for this tool are homeowners, builders, local authorities, or even nonprofit organizations like Build Change, World Bank, and so on, who are basically intercepting or doing intervention projects in developing world. And the vision of this project is ultimately to create an intelligent quality assurance tool to help promote safe construction practices around the world, and especially in areas with lack of technical assistance. So as Bob mentioned earlier, we work in areas which are more prone to disasters. So in those areas, especially when we're doing like high volume of construction, the task of construction supervision can become difficult, and also the homeowners may not be able to afford or may not have access to engineers on the field. So we hope that this tool will serve as an aid in that process and help promote safe construction practices. And in terms of the housing typology, so while this tool can be used in any context in any part of the world, basically, but the quality checks that we have developed so far are particularly tailored for the non-engineered or informal kind of buildings, which may not have an existing designs or plans, and they have a generic set of recommendations that need to be followed to build the house. So basically, the checks we've developed mainly look at those elements pertaining to the confined masonry or the non-engineered kind of buildings. So in order to create a construction supervision tool for this kind of typology of houses, we have to look at the quality of individual construction elements, such as mainly the walls, the rebar stirrups, which are used to tie the rebar columns, and so on. And also we have to look at the overall assembly, basically, for example, how the mortar units or the building blocks have been stacked in the wall, and the thickness of mortar joints, and horizontally and vertically. So things like that. So we basically have to break down the task of construction supervision into a series of quality checks. So when I mention a quality check, it pertains to assessment of a specific construction element, and its categorization as a compliant or non-compliant, or what we call go or no-go. And we classify images into these categories based on a certain criteria. So the specific criteria can differ from country to country, but the specific threshold that is, but we can do an approximate estimate of the quality based on these on the provided guidelines. So in case of the confined masonry construction, the general recommended guidelines are like very simple. For example, the openings have to be aligned more or less vertically, and they have to be continuous. The masonry walls are the main construction component or in the confined masonry houses. So they are the main load-bearing element. So they have to be built up to a certain quality in order to be able to perform better in disasters. So we're looking at some of the elements or assessments we can do is things like looking at the pattern of how the bricks or the blocks are stacked. And looking at also another check we can do is looking at the percentage of openings in the walls. So these are the quality checks examples that we can implement. So now let's look at what we have developed so far. In terms of the mobile app, we have a standalone React Native app. And at the moment, the user can go through a series of quality checks, and they have to follow certain instructions or protocol to take a picture, like in order to take a picture of a construction element. And they can send that picture, and the app will run the checks online, and it will output a go or no go for each check. And we also have added a functionality to allow for filter of the checks depending on the location. So let's say if we have a check that is specific to a country like Colombia or Nepal, that only is applicable to that context, then it will automatically be filtered based on where the user is using the tool from. And then to supplement that, we have a web platform, which is basically a multifunctional app that was developed using Django framework. And basically, it tailors to different users. For example, for general users, they can use the tool to just carry out some of the checks using a browser, and also view the images that have been assessed and the results and overall stats. For more admin users, they can use the web platform to manage the check implementation pipeline that is set up to carry out the check in the mobile app. And you can also add new checks or contribute data set, for example, images and any other public contributions, for example, resources that you might you recommend or that might be helpful for this project, that can also be contributed from the web platform. And within hosted in this in the web platform and the mobile app are a set of quality checks, as I mentioned. And some of the checks that we have developed so far are for the wall check, we have things like the bond pattern checks and assessment of the mortar joint thickness. We also have a check to look at the quality or the texture of the rebar, and also look at the presence or absence of rust in the rebar. And we have another check to look at the type of hook that is used or the stirrup used to tie the rebar column, and the shape of the rebar. So we have, as I mentioned, we have developed some of these checks so far, but we can grow this into a catalog of variety of quality checks that are applicable to a wider context and also a different typology of houses. And some of the features that we plan to implement in the future are adding offline functionality. So currently the mobile app runs online, and we hope to also implement this, the checks offline. And also we hope to implement language support and carry out automatic detection of objects, so the user doesn't necessarily have to crop or take a picture in a certain following a certain protocol. So how can you contribute? So to contribute, there's several things you can contribute in this project. Some of the short-term improvements you can support us with is by helping to improve the user interface of the mobile and the web platform. You can contribute image dataset to train for future machine learning training. So there are a variety of construction elements and images of construction sites. You can help crowdsource from the web platform. If you're interested and you'd like to learn, you can also help train new models or object detection models to detect an element or to classify or to carry out an assessment to build a new quality check that can be added to our catalog of checks. And in the long term, we envision to also integrate technologies such as AR and be able to obtain precise measurements of the construction elements, so we can carry out more accurate estimations and assessments via the mobile app. So you can check out the ISAC-SIMO GitHub repository, and also you can look at the ISAC-SIMO.net docs page, where you will find more information on using the tool and also how you can contribute as well. So definitely check this out after the session. So now, before moving on to looking at the building blocks of a quality check, let's look at the demo of the quality checks that I mentioned earlier. So let's look at the mobile app first. Let me know if you are not able to see the mobile app interface. So basically, you can download the ISAC-SIMO mobile app in an Android device or an Android emulator for now. And you can just search for ISAC-SIMO in the Play Store, and you will, once downloaded, you will see the app icon like this. And if you are simply wanting to test out the existing quality checks, you don't necessarily need to log in or create or sign up. So for now, we'll just skip authentication. And you can, to test out the quality checks, you can click on quality check option, and you'll see the list of the checks available. And from this, for now, we can look at a rebar shape example. So basically, you'll see the image. The image you see is basically how you're expected to take a picture of the element for this check. So you can you'll find the instructions to take a picture here, and then you can either attach the image from gallery or take, if you're in front of a building, you can take, or you have access to these construction elements, then you can take a picture of that element. So let me go to the test images. So since we are looking at the rebar shape example, some of the example images are here, so we can just attach any of the image and click submit. And this will run the check or the implementation steps in the background. And once completed, you will see the result as go or no go. Let me see if my wife. Sorry, my internet may not be as strong. Let me try again. Let me see. Okay. So as you can see, it will output a go or no-go output and a score. So in this case, the image that we took corresponds to a go case, since it's supposed to be a rectangular rebar with this kind of hook. If we select another type of rebar, for example, a triangular shaped rebar, which is not acceptable for confined masonry kind of houses, so it should output a no-go. And yeah, so this is the example, and we can look at one more example. So for the wall check, let's go to an example image. So these are the examples of walls with correct bond pattern and also the correct thickness of mortar joints. So let's see the assessment for this example picture. So in this case, the output was customized to output multiple check results, because the same image can be used to assess multiple features. So you'll see the number of bricks detected, the bond pattern, the horizontal mortar thickness check, and the vertical mortar thickness check. So all of these are compliant in this case. So you'll see output go in all of these checks. If we select another example image, for example, if we take a look at this picture, it has the mortar joint thickness is okay, but there is continuous. The bond pattern for these 3 rows are not compliant, so it should still output a no-go for bond pattern. So as you see, the horizontal mortar thickness and the vertical mortar thickness results are go, but because of these 3 rows, it has identified the bond pattern check to be a no-go. So these are some of the examples of the checks we have implemented. Now let's look at the web platform. So to access the web platform, you can just type ISAC-SIMO.net on your browser, and you'll see you'll land on a page like this. And if you if you want to just test out those quality checks from the from the browser, you don't need to log in as well. You can log in for more to see more advanced features and to manage the checks later on. So let's take a quick look at the same checks that can be tested from the browser. So in this case as well, you'll see the instructions to take the picture, and then you can attach a picture of a rebar in this case and click on test image. And once tested, it will output the result, go or no go, and the score. And when you test from the web browser, you can also view the outputs of each step of the implementation pipeline and see what was detected, if the hook was detected, for example. So yeah, you can test as a developer, you can use the web platform to test the checks. So going back to the tutorial slides. So now let's look at the building blocks of a quality check. So as you saw in the example, first the user will see the set of checks that are available for that context, and then for now you'll see instructions to take a picture for that specific element. And this can be replaced if you have an object detection model that you have built, then we can replace this step with the object detection model, and that will automatically detect that specific object, and we can crop that region of interest. And once that, so based on that image, we can then add a pre-processing step. This is an optional step, but might be useful in certain checks. For example, in case of rebar shape check and the wall check, we are only interested in the pattern or the shape of the rebar. So in that case, the texture or the other features don't matter. So in that case, it generally becomes easier to train a model using those pre-processed images. So we can set up a pre-processing step. And then for the post-processing step, we can implement an object detection or classification, or even a Python script that uses to carry out further image processing to finally compute the go or no-go output. So we have the pre-processing step, the post-processing step, and we can set up multiple steps for each of these, for each like pre-processing or post-processing steps. So as I mentioned, so in the first step for object detection, that's an optional step. So we can either add a object detection model for that specific check that recognizes that element of interest, or we can simply add instructions for the user to take a picture in a certain way. And then in the second step, we can implement a pre-processing script using simple OpenCV library functions that can process the raw image, or we can, in case of walls, for example, where we have a lot of variety of texture and the kinds of blocks used, in that case, we found it more accurate to implement a deep learning segmentation model, which is able to extract the mortar regions so that we are interested in assessing. So yeah, we can implement either of those steps if needed for our check. And then in the post-processing step, what we have done in this example is basically using those pre-processed image, we can further analyze features such as the vertical and horizontal mortar lines. We can analyze, based on the centroids of those contours that are found, we can compute whether the bond pattern is compliant or non-compliant. So basically, we can add a post-processing Python script to analyze those features and finally output the results as the custom result or simply a go or no-go output. So in this example implementation for the wall check that I gave a demo of, for that we first pre-process the raw image using the segmentation model. In this case, we used the unit architecture. And then using the mask image, we added a Python script to compute the centroid and other features to calculate approximately whether the bond pattern is compliant or non-compliant, and also whether the thickness of the mortar joints are compliant or non-compliant. And in another example, we have implemented a slightly different pipeline, but basically the same step, like pre-processing, post-processing, and then the final output. So in this case, we were able to pre-process the image using simple OpenCV functions, and then we implemented a classification model to be able to categorize the shape of the rebar as go or no-go. So go if it's rectangular and no-go if it's non-rectangular. And then we implemented a second object detection model to be able to detect the kind of hooks that needs to be present in this context. And if it's and by combining the outputs of go or no-go outputs of these two steps, we can add a Python script to output the final result, whether it's go or no-go. So now, in order to customize ISAC-SIMO, you can follow a similar pipeline as I showed, or you can customize as per the need of that specific check. So first thing you need to do is, before training a model, you would need to have enough image data set for creating a quality check for a specific construction element. So after preparing the data set, you would train a model if you're implementing a machine learning model to carry out that check. In some cases, you are able to implement a simple image processing script to carry out the assessment. And then for that model to supplement, as I showed, like how we can use a combination, instead of just using one model to assess different features, we can implement multiple models. That way we are able to focus on specific feature and like combine the outputs of different models to output a final go or no go in the mobile app. And then once you have all these steps ready, you can set up, you can deploy your model in ISAC-SIMO platform. So quickly, let's go over how you can prepare the data set. So you can use cloud annotations, and you'll find all these detailed information in the tutorial page that Daniel has shared earlier in the chat. So if you're preparing data set for a classification or object detection model, you can use cloud annotations platform, and then you can use train the model directly from there by clicking on Train in Colab. But let's say if you are creating another kind of, if you need to prepare a data set for segmentation model, for example, where we are training a model to recognize the motor regions. In this case, for example, you would need to use any free photo editing tools or Photoshop and create, you'll have to manually create a data set like this to supplement the raw image data set. So instead of the go or no go labeled data set in case of classification model, we would need to have mask image to train a model for segmentation. So once you have prepared your data set, you can experiment with different architectures of models, or depending on your familiarity with the machine learning, and also if you prefer to use a drag or drop interface to start with, and then later move on to more like offline based models using TensorFlow, you can try out different frameworks and these different tools. And some of the examples here are like you can create a new CNN model from scratch, or you can use an existing, like you can use transfer learning to basically like retrain certain parameters and like use an trained model, pre-existing parameters from the trained model, and then you can customize it the later layers of model. So this way, what happens is it's easier. It might be easier for you to train, and you might be able to get a better accuracy in some cases using this approach. And in case of a segmentation model, you can use UNet. This is what we used for the wall check segmentation. But of course, you can experiment with different variety of architectures. And once you have once you have reached a stage with you have reached a sufficient accuracy after training the model, you can add a pre-processing or post-processing steps if needed. So in case of pre-processing step, basically if the image data set that you have trained is not using directly the raw image, you can set up a Python script to pre-process that image automatically each time an image is captured for that quality check. And then you can implement one or more steps for post-processing steps and combine the output of all your models. And this is an example of a script that combines the classification model for rebar shape classification, and then object detection model for the detection of the hooks in the rebar, and outputs a final go or no go. So this way you can combine the results of your different models. And finally, you can deploy the model in ISAC-SIMO by registering to be an admin user in the platform. And once you've been approved, you will be able to access these all of these elements in the menu, and you can add your you can upload your models, and you can add your Python scripts, and you can organize them in the order of implementation that's applicable for your check. So these are all the useful links that you can find out more about the project. You can go through the detailed tutorial that will basically cover the same things that I've gone over in this presentation. And yeah, we can look at more demo of the web platform, or start with questions.
All right. Great. Thank you, Lakshana. So I'm just looking in the chat for any sort of questions. I know there were some questions around the implementation of, it seems, the Android app, which we had mentioned is made in React Native, so JavaScript, HTML, JSX. Those are the technologies there. The other question was, is there a set of the data set of all the images available already? Nirmal had answered that, but there are some in the ISAC-SIMO folder. Are there any other places that maybe people can find data sets?
So to train a new model?
Yeah. How would you suggest?
So far we basically we've used a combination of synthetically generated image data sets. So for example, in case of the rebar stirrup shapes, in that case, one of the reasons we used the pre-processing step was because we generated, using 3D modeling, images like screenshots of the rebar, and then we pre-process them. And we also combine it with real world images of rebar, and then use the combination of those images, because we couldn't find, there aren't many available images of just rebar stirrup, and specifically taken in that specific manner that we needed to assess. So in that case, in some cases, you might be able to deploy 3D modeling to create synthetic image data set. In other cases, like the wall, to train the segmentation model, in that case, we need a raw image, because we are training a model to be able to extract the key features from an image, from the raw image, basically. So for that case, we recommend you to just like find data set from online and like use image augmentation. We had roughly around 400 to 500 images, raw images, and then we used cropping of like rotations and all the different augmentation like steps that can be done to increase your data set for training. So usually, yeah, that's what I recommend for finding the images.
Yeah, you make a really good point, Lakshana. You can use 3D engines, something like Unity or Unreal, where you can get really realistic graphics, and then from there, take screenshots and then augment them. So then you have a larger data set. So I think that was very smart for the project. And I recommend that also for anyone who's watching. So I have one question while we wait for others. Where do you see ISAC-SIMO going? What do you think is the next level? Because of course, the platform allows you to create different models, but where do you think ISAC-SIMO could be used the most?
Right. So I think ultimately, and maybe Bob, feel free to chime in, we envision that once we have a wide catalog, once we have developed a wide catalog of different checks and models, we hope that we can help homeowners, builders, and all the non-technical people in the field to be able to assess the different construction elements around them. We can also further branch it out to assess like specific things like earth, as you have worked on, Pedro, on assessing earthquake damages, or even any kind of assessments basically that implements multiple pipelines of that can benefit from this kind of architecture and framework. That reminds me, we also have, if you're interested to deploy this tool for different contexts, or you are interested in implementing, using this from scratch, you can use the light version of the tools, and you can customize it as per the needs of your project for future use.
Yeah, I think that was good. I'd say a couple of things. One is we did use a lot of synthetic data the first time for the training. We do want to incorporate some more real world data, so that it's, improves the accuracy of the models. But also, as Luciano was saying, expand. These are two specific checks. There's a lot more, so it's expand so we can do more and more automation of the construction and verification. But then look to expand it. So every place right now that it takes experts in the field to do work, are there things we can do to automate more and more of that so it can be accessible to more people?
Yeah, great. Go ahead, Dan.
I was going to say, so beyond adding new models, it sounds like we also, I know we're interested in some new techniques, right? So improving the quality of the models that are created. I know, Lakshana, one of the things that you run into was perspective transforms. Is there something, if someone's an expert, a data scientist, how they might be able to address that issue? Maybe you can explain what it is and how improving that approach can help improve the overall models.
For sure. Yeah, so we tried to optimize with the limited data set as we were beginning to work on developing these checks. So the way we tried to optimize it was by setting up a specific protocol of steps that needed to be followed. So for example, the user would need to take a picture of a wall from the straight perspective so that we don't need to train the model on a wide variety of data set, which we don't yet have available. So, but in the future, what might benefit is like even if a user doesn't specifically take a picture in the right perspective, how can we fix that automatically and detect that automatically and still be able to carry out these assessments? So we may not be able to have a robust model that can work on any context or any kind of perspective, but we might be able to hack it in some way by adding a pre-processing step which can fix that before it gets passed on to the model.
Awesome. And I see that Nirmal commented in the chat. In the future, it will help to access pre and post-disaster buildings and check the quality of houses by homeowner without the need of an expert engineer. Great comment there. I think in the future, once robots are more mainstream, today we have drones that could inspect properties and they're autonomous. In the future, imagine, especially after a disaster, humanoid robots can come in and do those inspections. So I think that ISAC-SIMO and Build Change is laying like the groundwork for that future. So amazing job.
Yeah, and just as a declaration, Nirmal is actually on our team in Nepal. So you see him answering a lot of the questions. He someone else that's a great resource for diving into the details of this.
Excellent. Okay, so while we're getting some final questions, we have 3 minutes left. So let me just share some of the resources available if you are interested in learning more about the project and meeting the team and taking part. So number one, we have a bunch of these open source projects, as I mentioned, at developer.ibm.com/call-for-code. You can find those racial justice projects or the climate change related ones, the natural disaster ones here. So if you click through, you'll see that we do have links to the ISAC-SIMO GitHub repository, the README to learn about the main project, and as well as contributing in the open source community. So there is an organization for ISAC-SIMO. You can check out the 3 repos, as well as those light instances, which are the scheme framework of the system that's actually in place right now, which are the other 2 repos. And then ISAC-SIMO.net, if you scroll down, as you'll learn in the tutorial, if you go to the bottom, there's a way to check out the video, see it in action, learn about site, and then actually go ahead and try it out, and then eventually contribute back to the project at GitHub. So check out those resources. And there's also a nice tutorial that Lakshana and Pedro have put together that takes you through in about an hour the end-to-end process So we really recommend you take a look at that. You can download the APK from the Google Play Store. You can get access to the hosted instance and take yourself through the data science steps, learning about the important sorts of work that Build Change does in assessing building quality. And this also includes some of the great information that was in the presentation from Bob and Lakshana. So I encourage you to take a look at that. Yep, and Nirmal posted a link to the video as well. I don't see any additional questions, but if you do have them, we do have Slack. If you go back to the call for code page and you do this get started, there are the 4 steps I had mentioned earlier. You can get yourself a cloud account. You can then join the community, and then you can find our Slack community. So if you go to callforcode.org/Slack, you can go ahead and join Slack. And one of the default channels is actually the ISAC-SIMO channel. So you can carry on the conversation there, as well as through the GitHub issues. So with that, we're at the top of the hour. I don't see any more questions in the chat. So hopefully folks have some chance to take a look at those resources and follow up with the team in the future here. All right. Well, I want to thank everybody for being part of the webcast. So Lakshana and Bob, thank you so much for showing the great work you've been working on the past year and a half. And Pedro, thank you for highlighting some of the other aspects of the Call for Code program and how folks can use emerging technologies like augmented reality to help improve this project. So with that, thank you very much, and we'll see you soon.
Awesome. Thank you.
Everyone.
All right.
Bye.